Hello, everyone, and welcome back to the First and Focus speaker series. My name is Varun, and our other host for today is Alina. Tonight, we have Ryan Donio and Sam Dare from Thrifty Bot, a company which offers affordable equipment and parts commonly used in competitive robotics. Our focus will be specifically on the Thrifty Swerve module and Swerve drives in general. Questions will be answered at the end, so feel free to drop any questions you might have about Thrifty Bot in the Q&A box during the presentation. Now, without further ado, take it away, Ryan and Sam.
Thanks, Varun.
Thank you, Varun. Yeah, thanks for having us. First of all, really appreciate the opportunity to present to you guys and talk. So my name is Ryan Donio, and joining me is Sam Dare. A little bit about ourselves. I've been in FRC involved since the early 2000s. That was kind of when I was in high school, and I've been involved as a mentor on various teams throughout the years here. Most recently, I mentored 1720, and that's a little bit about me. Sam, do you want to tell about yourself?
Yes, I started in the aerial assist off season. My first event was actually the event put on by Ryan, the Gateway Robotics competition, and that's when I met Ryan. And I was in charge of 4256 for a little bit. And then when I went to school, I was looking for a team that I wouldn't have to do much with. And 2767 fit that bill because they don't really need much help. They're doing pretty good on their own. But I've been able to mentor them a little bit. Obviously, I'm in college, and mentoring in college is very difficult and not highly recommended. But I was able to do a little bit, and I'm happy with that. And I started with Ryan last summer.
Awesome. Thanks, Sam. So we're going to go into a little bit, I guess, about what Thrifty Bot is for people that have never even heard of it, which I find all the time. There are people that still haven't heard of us, which is cool. But it was established in kind of mid 2019. The website is thethriftybot.com. And really our mission is to provide high quality, low cost, commonly used parts to FIRST robotics teams. We started with 1/2-inch hex bearings and 1/2-inch hex shaft collars. Those are kind of the two things that were first on my list. The way that whole thing kind of went down was I just figured out how to source these items, and being an extremely small operation, we're able to source things, and since we don't have a ton of overhead, we can turn those around and give them to teams for a lower price point. So teams really like that. FRC is expensive. For a long time, in my opinion, FIRST has kind of had a sustainability problem with teams just because you need a large budget to operate. So this kind of helps teams save money in the long run and spread those costs out. I guess people agreed with it because we kind of took a shot on just those two items, and from there we've grown to over 35 items that you can buy on the website today, and we're constantly growing. Even during the pandemic, we've introduced new items, so really appreciate all the support from everyone. That's been really cool to see. And I've partnered, with other FRC mentors to help design some new products as well. Previously, the vectored intake wheel that you might have seen some go out of stock in 2020, that was working with another mentor. I love working with others, right, and collaborating. So it's been really cool to be able to team up here with Sam. And Sam mentors, like he said, the 2767 FRC Team Strike Force. And he designed Thrifty Swerve really from the ground up. It's been really cool to see that. And he's continued to design products, and he's working with me on Thrifty Bot stuff. So Sam, I don't know if you had more to add on that or.
Yeah, I mean, I took it on because I just kind of wanted to be helpful and wanted to do some more things to grow myself. I had never really brought a product to market from scratch before, so that was the big experience with the Thrifty Swerve, that we've now gone on to do some other products, but none quite as big as that.
Right, and that was by far the most complicated thing that I think that we brought to market so far. Everything else before that was kind of one item, or maybe it had some bolts and nuts and spacers and things, but this was by far the most complex project so far. So a little bit, I guess, Swerve history here is what this slide's called. So if you don't know about Strikeforce in 2767, they have this fantastic white paper called the Third Coast Swerve white paper. They're based out of Michigan, so it's kind of fun to call, there's East Coast Swerve and West Coast Drive. There's Third Coast Swerve is kind of a fun name, I think. We really saw this as kind of an opportunity to bring a different flavor of Swerve Drive to the market at an affordable price. That's what we were really trying to go for here with Thrifty Swerve. This first picture that I had took from that white paper is kind of the known, really tried and true Strikeforce design that you see there. World champion Swerve there. The second picture is one that we had adapted on 1720 for 2018 season. We ran Swerve Drive and heavily inspired by Strikeforce's design. We changed a few things, but it was mostly what they did, and it worked really well for us. We had some learning curve, right? Like a lot of teams do with Swerve, especially around controls, but we enjoyed it. But with Thrifty Swerve here, we're trying to make the Swerve Drive more accessible for really that mid-level FRC team who may be really solid with using like the kit drive and is feeling more comfortable with their controls aspects, but might not have all the machining resources to make some of this stuff. These are pretty high precision parts, the tolerances you have to hit for it. So just providing some of those things to teams, like the bevel gear sets as their own parts, those kinds of things. And leveraging 3D printing is the other aspect behind this Swerve that we really focused on. I have 5 Mark Forged Onyx One printers in my garage, and that's what produce the vectored intake wheels in large part. And the experience was so good with that product and producing parts constantly on them that we felt really comfortable trying to produce some of the parts of Thrifty Swerve using those printers as well.
So if I can step in here, Strikeforce has been evolving their Swerve since long before I was on the team, and they have truly come a long, long way. Their first Swerves they were not happy with, and they just continued to iterate and iterate, and they're still iterating. The most recent version, when I first joined the team, they were experimenting with overmolded wheels, which was so much work. And basically everything on the Swerve is custom, and it's just a ton of non-COTS high precision parts. They even make their own similes. Now they use Falcons, but they used 775 Pros, and they were making their own gearboxes because they wanted everything to be that precise. The tolerances on Strikeforce are very, very challenging for nearly any other FRC team to hit. So this product was designed to be a lot more accessible to pretty much everyone.
Yeah, absolutely. And just the last bullet point here, some of the stuff you'll see if we get to share videos at some point, you'll see some of this was tested at actually Sam's college. Some of it was tested at Strikeforce's facility, just with the pandemic and everything going on. Like we were really just trying to test anywhere we could, and whoever was willing to help us. So I mean, just a huge thanks to those guys, because I don't know that we would have been able to pull this off without some of that help.
We wouldn't have.
So this slide's super crowded. There's a lot here. We tried to think back to 2020, which was a crazy year, just in general, right? But you know, the season shut down in 2020, went on hiatus, and vectored intake wheel production went to a screeching halt, and you know, everything kind of slowed down. And kind of early on in 2020, Sam, you know, you were developing the design that really became Thrifty Swerve over that.
Do you want me to walk through it?
Yeah, feel free.
The initial Swerve was, okay, how as light as possible. So we started looking at, okay, we could use one wheel, we could do kind of like a offset design, and quickly ran into some problems with that I'm not going to go deep into. But basically, we realized that if we were going to minimize the amount of gears, we'd have to do the bevel in the middle and two wheels. And that was kind of what started driving the design. And so initially we had this pulley on the outside, and then packed by using an internal gear. And so then once we had the internal gear, we had the problem of, oh, well, how do we fit an encoder in there? And how do we do that compactly? Because we don't have much room inside of the internal gear. We could do it beneath, but then we have problems with mounting. And so the solution we came up with was this really cool part that's probably one of, if not my favorite parts in the entire thing, which is the encoder gear shaft integrated printed part. So all that stuff is spinning relatively slowly. I mean, that's not like it's not blazing fast. And so we saw no need for it to actually have bearings. And a lot of people, when we first released it, said, whoa, you need bearings. And we had to push back that we have tested this. This is, I know it's scary that there's no bearings in it, but it does work. And basically we just went with as many bushings as possible so we could reduce the weight, we could reduce the amount of parts, and they weren't needed. And there were some bushing swerves eons ago, back when Ryan was in FRC at first, long before I came around. He's old. And I'm kidding, but we started, yeah. We started going down that path of using as many bushings as possible. And I really like the Delrin bushing we came up with. Initially, we actually had printed bushing, which was, and then throughout the summer, we were using printed bushings and printed saddles because we wanted to get as much printed as possible to get it as light as possible. And quickly we realized that Ryan didn't really want to spend that much time printing things. I mean, he already spent way too much time printing things and will continue to do so, but we tried to keep the printing to a minimum as far as what was possible to be machined quickly overseas. That's what we went with instead of just printing everything. Another problem that we hit, which was really, really hard to solve until we just started machining them, is the bushing. The printed bushing would not print round. And this is actually a little known Markforged issue. Markforged will not print round bushings. And
Perfectly cylindrical.
Yes, perfectly cylindrical. Yeah. It'll print round-ish, but once you start using it as a bushing, it gets out of whack. So we started turning those down on a lathe, and we realized quickly we could not do that at scale. Mostly because I didn't want to sit in front of a lathe for hundreds of hours just for a bushing. But that was another challenge we hit. And then we had the challenge of actually making the 4 modules and starting to actually drive that, and finding some people that were willing to help us with software, because neither of us really is great in that area. So once we were able to actually turn the thing on, well, first we had a corner drive, and you'll see pictures of that. And the Strike Force mentors actually taught me how to program a PID loop. And that was a fun experience. That was a nice evening. I spent a lot of time with them and at their facility, and I'm extremely grateful to them again. But once we had developed one, and then we changed very, very little after that one, because we were very focused on getting one built right. And I think each part went through 5 or 6 different prints, and we wanted all the tolerances to feel as close to perfect as possible. So then when we came to actually assemble 4, or once we assembled 1, then we assembled 4, and then it came together pretty quickly. We wired it up in a day or 2, and we're driving around pretty well, and we were really happy with it. But then we had to get the more scalable version, which was the next hurdle. Kind of in September, we had to develop an all metal saddle, mostly based on feedback from the community that they wanted one. So we gave it to them. I think Ryan and I both really agree with the fact that if customers want something, we're going to give it to them.
Yeah.
And
yeah, that was one of the cooler things. I mean, yes, when we put this out for pre-order, it was like end of September, right at the end of September, I think. And we got a lot of feedback during that kind of month period of where we'd said we'd sit for a minute, see how many pre-orders we got, because we just didn't know how many to make either.
mm-hmm.
Really hard to predict that kind of thing with having no data. So yeah, and then we'd get, there were concerns about the printed saddle, like you said, and getting that metal wheel saddle sample, like it just felt so solid. So it was kind of a no-brainer. It actually ended up costing less than the printed one, so that was cool. But yeah, keep going. Sorry for interrupting.
No worries, that's all good. So like Ryan said, we took a lot of community feedback in October, and I was reading Chief Delphi during class and getting back from class and catting away. And it was just this really nice back and forth. Ryan and I have both gotten a lot better with just communicating quickly and iterating very quickly. It's really nice when you have such a small organization that one person thinks you need to change, you can get it changed just like that. So then we had to develop the assembly videos and assembly guide. And I don't think either of us had really made anything quite that extreme for an assembly guide or video. So that was definitely a challenge that we had. And mine was much simpler when I sent it over, and Ryan was able to make it much more in depth, getting some CAD screenshots. And then the videos he produced are really nice, especially the tread assembly one.
Shout out to all the other suppliers, man. There is so much work that in that documentation process. And there's some really good stuff out there that everyone else has produced. So, I mean, yeah, I don't think you realize just how much work goes into teaching someone how to try to build something until you put it together. So,
right, because when we were assembling them, it was, oh, you just put this part on this, and we knew how to do it because we designed it. So it was definitely a lot more challenging to teach other people that had never touched it. And then we started working on making everything better and lighter again. So we looked at ultraplanetary support, which was pretty simple to add. We just had to come up with a shaft, and that launched, I think, a little bit later, but we're happy with how that turned out as well. We just wanted to make sure it was 100% ready for teams. We never want to sell anything that isn't ready. And yeah, then we lightened the gear and the saddle, and I think we took off 1/8 of a pound, which that doesn't sound like a lot, but since you got to have 3 or 4 modules, that's half a pound right there. And I don't know about you guys, but my teams are usually pushing half a pound overweight, so any little thing we can do helps.
Yeah, absolutely. I weighed the new fully assembled 1.1 module today, and it was, I think, around 4.25. So it's pretty light.
Mm-hmm.
Get under 3 someday.
I was thinking under
Or
4.
under 4, sorry. Under 3 would be insane.
I don't think you
All
can
right.
get under 3 with physical materials, but the goal is to get under 4 eventually.
Yeah.
So yeah, this is the left is the corner drive that I was just talking about. The initial unit actually had an 8mm shaft going all the way through, and then we used a 12-tooth gear that we pressed into a 21-tooth gear for that middle gear, and the printed gear actually held up pretty well. That was kind of the inspiration for the printed insert that we now sell on Thrifty, because splines are better than hexes and hexes strip, but the teeth are usually good on printed gears. So we were surprised by how well that held up, but it wasn't holding up well enough to sell it and have it last for years. So we explored a metal option after that and just switched to a 3/8 hex on the bevel. And yeah, we just welded a couple pieces of 1x1 together and eventually put some legs on it so we could tune the quarter drive. And we actually built everything up so we could test the current draw. And then I think we went through a couple revisions of that top plate based on current draw, so that we could space the gear over a little more because it was grinding on the internal gear. And then we actually had a printed top plate, and it needed to be twice as thick, so we didn't need that printed spacer, which was kind of fun to just see this big chunky plastic brick that the motors get hooked up to. I didn't like it so much though, because there's no way of dissipating heat from the motor, and it just made more sense to make the other piece metal. And the 1/4-inch plastic piece was actually super wobbly, and I was surprised by that because I'd heard some teams had used a nylon motor plate and it was never going to work. So we had to beef that up.
Going to the rigid top plate. There's the other ones you had of your test bed setup.
Yeah, so that's Strikeforce's test setup, which we were fortunate enough to get to use. We had one computer running TCT, which is Third Coast Telemetry. It's their custom ASCII-based control software that you can tune a PID loop from. And then we had their grapher, so we were looking at different amperages and testing motors at different speeds just to see how it all performed from a control standpoint. And I don't really know how other teams tune PIDs without a graph, because the graph makes it so helpful. And that's all available on Strikeforce's website if you guys want to check that out. And then, yeah, on the right is our first 4 modules built up. You can see the aluminum motor plate, which was different from the previous rendition, like I said. And we wired it. It was a disaster of a wiring job.
It's, it's a prototype.
Yeah.
As long as you don't have electrical issues.
We didn't. It worked first try. I'm an electrical engineer, and that was actually the first FRC robot I've wired, which is kind of sad. But that first one weighed 4.5 pounds, and that's not using the Neo 550. Strikeforce does not use the Neo motors because they believe the CTRE stuff has just been around longer and they're more familiar with it.
Yeah, 1720, we're on the Neo train, and we've had our modules running with the 550 on the Ultraplanetary, and so far so good. We drove it a little bit. We haven't gotten much stick time on it yet.
Oh, and this still has printed saddles as well.
Yeah.
And printed wheels. And the wheels actually had to have carbon fiber in them to avoid stripping out the hex. So we knew we were going to have to use metal wheels for production because we didn't have a carbon fiber continuous printer. And we had a aluminum 21 tooth gear from our first gear supplier, and it just got destroyed.
Turned to dust.
Yeah, you can see the dust on that top plate. And then on the right there is all the samples were ordered. That was before we put the sloth hole in there for the encoder. That's what we're calling it now. I don't know if that can be the official term, but
I mean, that's what Discord calls it. And it's pretty
yeah.
So
So we have the sloth hole, or the sloth hole-less version on the right, and that is how the battery stayed for all of our destructive testing, which was a terrible idea. But yeah, we wired that at my college. They were gracious enough to let us use their robotics room. And yeah, that was our second full-scale model. And then we took it down to Strikeforce for driving, and we drove it off of a lot of platforms, and that was a lot of fun just trying to destroy it.
yeah, there's a good YouTube video up on Thrifty Bot's channel that shows you just like yeeting off of Hab 2 with it and driving over the berms back and with a fully weighted 130-pound chassis. And it handles it. I mean, it's pretty cool to watch.
Yeah, that was very entertaining just because of how much fun the Strikeforce mentors got out of watching that. They're like, you don't really want to do that, do you? I'm like, yeah, we do.
I mean, if we didn't do that, some other team's going to. You want to put it through the paces for sure.
Right.
Like that's always my philosophy is like, if I'm going to put this up on the website and sell it to a team, I need to know that it can take some abuse, because life happens, robots happen, right? Sometimes you got to push the limits on these things. So
absolutely, we wanted to prove that it could fall from about a Hab 2 level to simulate if there's anything like there was in 2019, and it was fine, no problems. I think we drove over the berm like a couple hundred times, and we finally had something break that wasn't actually part of the production module. So we were very, very happy with how it held up.
Yeah, and that was without any kind of skid protectors and
right
thing, just kind of brute forcing it,
which Strikeforce uses. And then after they saw our testing, they're like, oh, maybe we don't need those.
So those are your pictures. These are ones that I went through and found. And I mean, you can talk about these too. Some of the earliest ones I had found were the iterations of the printed internal ring gear.
Yeah.
Originally, we had integrated that with the encoder gear that's now a separate piece that just bolts in line with that. We had looked at using, and this is back when the saddle was printed. The challenge then was like, how are we going to, assemble this whole thing together? And we were like, well, we'll go up through the saddle and into some heat set inserts or something like that. And so we tried all of that. And, eventually once we went to the metal saddle, it really solved multiple issues because we could thread the holes in it and then just assemble from the top down instead. So that was
I think once we did that, we both just knew that was the way to do it.
So much easier.
The squeaking and the concerns that we had about these inserts and how many different revisions we went through with everything, because we went through a couple different washers even to space the gear. And then this just solved our problems, and we're like, okay, metal saddle it is.
Yeah, sometimes the solution presents itself and you go with it. So me and Sam being, hundreds of miles apart, he's in Michigan, I'm in Indiana, I would be printing things. So I actually printed the entire early module completely, bevels, everything, because I really wanted to just feel a module fit up in my hand and kind of get the size of everything, just play with it some. So that was a picture I had taken. That's just all Markforged Onyx, almost everything except for the actual bolts and bearings in it. We 3D printed a box to packaging instead of just buying one. We wanted to see what the volume was going to be needed for that, for shipping to teams. Originally, we had the triangular hole, and this is the sample wheel. So we got samples. That's what this picture is. We had gotten samples of all the major components that we were planning to have outsourced. And so all of those parts showed up. That's what this picture is. And I had apparently weighed that completely 3D printed module, and it was under a pound, which was like hilarious.
Go back one real
Okay.
quick. The bushing was a challenge, and we asked our manufacturer to produce 5 bushings within, I think, 2 thou of each other, so we could determine what was the best fit for the bushing. And that was like the tolerance of all tolerances. My college machine shop lead guy told me that was impossible to machine those with that much precision from a block of Delrin. And I was like, well, that's what we got to do. So it ended up working out.
And they were all different. I mean, it was kind of interesting plugging those into the aluminum plate and just feeling one was obviously way too tight and one was obviously way too loose, and then the others were close, and we kind of picked the best one out of that, and that's what we've gone with. And it's worked.
And we did actually try to print the bevel gears. Don't do that. It works great with one module. You can actually drive it really well on a test bench, but as soon as you put it on the ground and you have all the reactionary forces, it won't work.
Yeah. You can buy the bevels.
Yeah.
Just want the bevels. Some more pictures that I had through development. This was when we had designed the metal saddle. I printed one up first and plugged it into the module mock-up that we had and made sure that was going to work. That's kind of what we always do. We're going to print everything first and plug it in and make sure it works. And because one, Markforged printer is just incredible. So you're getting almost always like a part that's going to be the same or extremely close to what would be able to be machined. So you can really get a good feel for it. And then, so we did that, and you kind of see the bolts going through the whole assembly. I think that was like our aha, this is way better moment. I didn't have the right bolts, but it was so easy to put it together. The sloth hole, was the addition from Chief Delphi, which was a good one because some teams want to run their encoders inboard. For whatever reason, maybe the game has some precarious things that are necessitate that you don't want to put that on the outside. So we gave teams the option to do that. Started printing parts once we kind of locked in design. That there's a point in everything when you got to kind of draw the line in the sand, say we're not going to iterate anymore. This is it. And that was after Sloth whole edition.
And I think that was hard for us, is just finding an end timeline. That was just at some point, Ryan, I think, just called it. And
yeah, I think I did. I was like, we could probably keep changing things, but if we want this to be a reality for teams, the end of this year, into last year, we got to start going. So started printing the internal gears, and here's just like a box of printed parts. I was just like throwing everything in there at one point. It got sorted later. We printed the encoder case, the internal encoder gear, the external encoder gear, the bushing retainer piece. So all that's there. The spacer
Correct me if I'm
plate.
wrong, Ryan, but I think there's only 2 parts that have support at all.
Yeah, it's the external encoder gear and the
Encoder's piece.
encoder case.
Yeah.
Just the one, I think. So that's cool. So yeah, not a ton of supports to remove. The external encoder gear, I mean, there's a decent amount, but it's just kind of a weird shape. But it works. It works pretty well. And well, yeah, motor spacer plate. So we added in the hole pattern for the ultraplanetary from Rev. Teams were really vocal in their desire to want to try those. You know, initially this was kind of designed for VersaPlanetary only because that's what we both had hands-on experience with. But you know, we've 1720, we've run the ultraplanetaries now. I know some other teams are doing that. It seems to work. You know, you just got to be, like anything, you got to be pretty careful about assembly, making sure everything lines up and nothing's binding. But as long as you do that, you're okay. Just another picture of everything coming together there with the production. I took the early production modules to 1720, and once we had the instructions developed, or what I thought was going to be like the final version of the assembly instructions, I took it to the students and said, here, assemble this Swerve kit from just these pictures. And I learned a lot from that. There were, like, the first thing that happened was just parts got like dumped all over the table. And so I was like, okay, definitely need 2 pages of every single part laid out. Like I don't know, almost like an IKEA thing or something, or the Prusa printer you get where it's like, I see everything that's in this box and you can make sure you have it all. So that was kind of the big thing I learned from that, is that people get really excited and sometimes parts just all end up out on the table. So, so that was a good lesson learned. Around Christmas holiday period last year, everything showed up. So started kitting everything, getting the boxes ready to go. It was pretty neat to see that kind of that culmination of all the hard work and development and back and forth between me and Sam over those months. Finally put out the product, so that was cool.
Yeah, doing that during first semester of junior year of college was quite a challenge.
Yeah. Yeah, and so I mean, I don't know if we alluded to this, but yeah, like Sam, you're still in school, so you're doing that. Like, this is not my full-time job at all. My side gig, so I have a full-time job during the day too. So we're always trying our best, but you know, we've all got other stuff going on for sure.
Right. I graduated in a year, and I'm currently interning at Stryker. And Stryker is a wonderful company to work for any students listening.
So this picture was just the weight of that initial module. We were 4.36 pounds. And then we got the ultraplanetary 8mm keyed output shaft in, which was kind of necessary if you wanted to use it with our Swerve module easily, right? So we developed this shaft just to be able to kind of use those 8mm keyed gears. So those are all the pictures I had. That's kind of the whole gamut, I guess, of everything that happened. It was kind of a blur. I tried to throw a few successes down because I think we did something.
I hope so.
So, you know, we developed a completely new COTS Swerve option for teams, and we brought it to market. And we delivered it at a low price point. Even if we had to adjust it a couple times to hit that, what we thought was low wasn't really maybe what the community thought was low. So we reacted to that. But I still contest. You get a lot of hardware. You get a really good product for the price. And we had some teams use it on their 2021 Infinite Recharge at Home challenges. 3015, like I know they won some awards throwing it on their robot. 340 used it as well. The 3452, the Green Engineers up in Michigan, used it with some success. So it was really cool to see some of these teams be able to take our module and, in a pretty short amount of time, get it on a robot, get it running, and actually perform pretty highly with it.
I think we're both incredibly thankful for all the teams that took a chance on it and didn't leave us with a ton of stock.
Yeah, absolutely. And there were a few hiccups here and there, but teams were really cool. They passed feedback back to me, and if they had an issue with the part, we would send them a new one, or we'd help them work through the issue that they were seeing. So that was cool too, to just see the teams being willing to kind of work with us on it, because anytime you put something new out, there's always going to be a few things here and there that you just don't get perfect that first time. What else? So we've been continuing to work on Thrifty Swerve. Version 1.1 is what we're calling what's in stock now, and we've got some modules sitting on the shelf behind me. They're ready to ship out with the lightened gears, the lightened plates, lightened wheel saddle, and just some improved tolerances and improved fit up that on the feedback that we got from version 1. So. And just there's a lot of YouTube links here. I don't know if I play any of these videos, how well they'll actually go over the Zoom call, but
I think we're going to release this PowerPoint after, so if anyone really wants to watch them.
Yeah, definitely. I think that's all the slides I had. Yeah.
Thank y'all so much for a really good presentation. I sure enjoyed it. So now we're going to be moving to the Q&A section. So our first question is going to be, do you know if there's like a significant advantage to using Neo 550s over Falcon 500s over Neo 550s?
So
sorry, just regular Neos.
We've had a lot of internal and external debate about this. The benefit of doing it is you're running the motor closer to its peak power, and it's happier. It's going to have less current, and it's going to run more efficiently. That's the science of it. A high power, I would argue overpowered motor works, and our competitors have done that and done it with great success. But we preferred on this project to run it closer to its peak power and more efficiently to have less current draw.
All right, so second question is, how did y'all decide on the gearing for your Swerve? Was it just a bunch of testing, or how did that work?
So we wanted to use the 12-tooth gears as much as possible. That way teams can use the really cool profile shifted gears by Vex if they want to go a little bit faster or a little bit slower. But we found in the past that around 15 feet per second with Falcon 500s is optimal for the average game. So you can go a little bit slower if it's a smaller field and there's just smaller sprint distances, or you can go a little bit larger or a little bit higher speed if you think that you need higher sprint speed.
All right, so do you recommend that teams make modifications to the Thrifty Swerve module other than like motor choice?
Encoder choice is something they're going to have to work through.
Yeah. I mean, it would just depend on the mods, I guess, right? Like, I'd be curious what kind of mods they want to make. I mean, anytime you go down that path, for sure. Like, if you want to, I know some teams this year had developed like a dual motor input, right? Just for the infinite recharge at home game, because like you're gonna put motors on your drive. So it'd be interesting to see what teams wanted to do with that, I guess. I don't know. But
And I think a dual motor drive, the really cool thing about our Swerve is you can pretty much bolt anything to the top and you can pretty much bolt anything to the bottom. So if you want to use bigger wheels and you want to make your own saddle, go for it. If you want to have some further reduction on top or make some kind of shifting thing, go for it. We have this platform that's extraordinarily modular.
All right, so do you have a recommendation for teams on an ultraplanetary or versaplanetary gear ratio for the actual turning part of the module?
It's in the
yeah, it's in the
build
manual.
guide. I believe it's a 12 or it's a 21-to-1 if you're using a Banebot's 550 motor, or anywhere from a 9-to-1 to a 15-to-1 has worked with the ultraplanetary. Just depends how hot you want to run your PID loop and how good at tuning your PID loop you are, I guess.
All right, so what advice would you give to a team building their first Swerve drive?
That's a good one. I would say go COTS instead of building your own. In high school,
Yeah.
I built my own for the first time, and we spent a good chunk of the season just sitting there. And if any 4256 alumni are sitting there, they are watching this, they can be shaking their heads at me right now. But we eventually figured it out.
There's so many good COTS module options out there, right? And it lets you jump into the controls aspects a lot faster.
Mhm.
When we did the Strike Force copy clone kind of thing on 1728 in 2018, we spent so much time machining stuff that our controls problems lingered into our first event just because we didn't really get running quick enough. So that's the nice thing is, there's a lot of modules out there today. So if you pick one that you think you want to go with, you'll get up and running, at least mechanically, I think a lot faster.
And the controls aspect of Swerve has gotten a lot easier. WhippyLib has released some updated documentation for it. And there's a lot of teams using Swerve that didn't before. And I think a lot of that is the new power distribution board coming soon from Rev. If we could just get a bigger battery.
All right, so what material are all the drive gears made out of?
Those are steel, hardened steel.
Yeah, it's a hardened. I was trying to
4140 steel, I believe.
All right, so what's the main reason that y'all decided that y'all wanted to mark forge the encoder gear instead of make it out of metal?
One piece was a big thing. You're not going to make that out of one piece out of metal, and reducing the complexity of it. We don't need bearings because it's not turning that fast, and it can be plastic. Plastic is light, and we can just stick a magnet in the bottom. It's awesome.
Yeah,
or the top.
There were some things where we found that, like with the wheel saddle, and if we printed it, it actually ended up costing us more than just getting something machined. But this was something that really didn't cost a whole lot to make ourselves. There wasn't a ton of print time wrapped up in it, and like Sam said, the load just wasn't really there. That it needed to be metal.
If something can be lighter, we wanted to make it lighter to a point.
Yeah.
So do you foresee the Swerve drive becoming more popular in FRC as the future goes on and the Thrifty Swerve becomes more adopted, I guess?
Oh, definitely. We're fairly confident that that Swerve drive in general is the best drivetrain for teams, but it's going to become even easier to implement from a control standpoint. And then my hope is that it will eventually get to a point where that's the norm. There's most teams are running Swerve.
Yeah, I mean, Swerve certainly seems like the meta, right? The meta that is, especially this past season with everyone being at home and really being a driving challenge has taken over. I wouldn't necessarily say all teams should like jump into Swerve though, especially if there are other areas that you haven't mastered yet. But um, I think now is like Sam was saying, it's easier to get into now than it ever has been at the same time. So if it's something that, you know, you're looking for that next challenge and you're kind of maybe wanting to advance your team to that next level of competitiveness, Swerve might be able to get you there.
Absolutely.
So for the Thunder Hex bearing, have y'all seen a lot of wear in it throughout your testing?
No, not yet. I mean, so that vertical shaft is a 7075 aluminum one that's been anodized. It runs through a 3/8 Thunder Hex style. I mean, it's the same one. That's a 10.25 millimeter, and haven't had any issues with that yet, as far as I can tell. I haven't had teams communicate that back to me at least, and I know we haven't seen that.
All right, so for a team that, like, for example, has seen a bunch of wear in that bearing, what would you say to modify the module to make it work?
Contact us.
Yeah.
There's
Yeah,
probably something else going on.
We want to see pictures. Yeah, if teams are seeing that happen. So like one team, I won't say who they were, but they had the modules, and this is, I guess, unrelated, but they were seeing a lot of wear and rubbing on the big 3D printed internal gear. We come to find out that they had assembled the modules incorrectly and had put retaining bolts into the end of their Falcon motors on the shaft, which the printed gear retains the pinions itself. You don't actually need those bolts, and there's no space for them. I'm not sure how they would have assembled it with them in there, but they did, and they ran it, and it just totally shredded those gears. So we printed new ones, sent them to them for free and everything. And it's just things like that. Now in the assembly guide, there's big red text on one of the margins that says, do not put retaining bolts in the end of your Falcon shaft or the end of your ultraplanetary output shaft, because it will grind into that gear.
So do y'all plan to continue making improvements to the Thrifty Swerve module?
We've got a couple in the pipeline right now.
Yeah, we see this as something that will continuously improve over time. And I'm not shy about rolling improvements into products as we get the next, iterations manufactured. Because I would rather teams that are buying it next get all the good stuff that we've learned out of the previous teams that have used them and given us that feedback.
And I really want to get it under 4 pounds.
All right, so do you think you would recommend a Swerve drive to like a rookie team?
Ooh.
No.
Not a real
No.
rookie team. Maybe like a rookie team that has.
Yeah, if you're a rookie and you're just starting out, you should use the Andy Mark kit chassis. I mean, if you're a team that is having a hard time making playoffs consistently, you should be using the kit drive. Because the kit drive, it just does like what basically these COT Swerve modules are starting to do for some teams. It's something you can put together immediately. You don't have to worry about machining and manufacturing everything. It's just there for you. And then you can focus on the challenge of what to do with it, right? Or how to make it go, how to make it work. So if you're early in your FRC journey, I can't say enough good things about the Andy Mark kit frame. I've used it for years on various teams I've mentored.
You've put a lot of blue banners with it too, haven't you?
Well, a few, but it works. It works great, and they've done the engineering. They've done a lot of the work on making that accessible. So if you're newer into FRC, consider it. No one should look down on a team that's using the kit drive, honestly, because it's a great choice.
Yeah, when we're scouting on Strike Force, that's a value add if they're using the kit of parts drivetrain.
All right, so what advice do you have for someone who's considering to like start their own business, for example?
I don't know if I'm the person to ask that. So like Thrifty Bot like runs out of my garage and out of my closet, right? Like I don't have an office. It's very much side hustle territory still at this point. But I think what I've proven, at least so far with Thrifty Bot, is if you start small and you aren't reliant necessarily on the revenue and you're able to reinvest that back into the business and to constantly, make or acquire new things that teams would want or products that people would want, you're going to grow faster. And that's helped me at least kind of beef the business up pretty quickly without investing a ton of my own personal income into it, because I've just taken things and kind of reinvested it at this point. So if you're able to do that, like that's a nice way to, I guess, grow organically is what I would say, versus throwing maybe a ton of capital at a business that you aren't really sure is going to take off initially.
And I think another thing is a lot of times it's really tempting to chase the cool things and the shiny objects. And Ryan did a really great job with hex bearings, which are not that cool. I mean, it's a fairly ordinary thing, but that's what initially started off and made all this possible.
Yeah, I mean, identify things that teams use every year, things that are consumables, and hope that people want to save some money. That was the idea behind it, at least.
And so far they have.
All right, so I think this is going to be the last question. What advice do you have for sourcing items, as you mentioned early in the show?
Just depends. I mean, a lot of my stuff I get manufactured out of the United States, but there's some things that I acquire within the US. I think you have to think about your lead time and what's your price point. Are you going to be able to, either use that on your team, or if you're selling it, can you turn it around and sell it for any kind of profit? But there's things that if you actually look around in the US, you can find suppliers that are pretty reasonably priced on some of this stuff. So, I guess say just start searching. There's sites where you can go on and look through suppliers, put requests for quotes out, and see what you get back.
All right, so I have one more question. What advice would you give to like FRC students in high school right now?
Stick with it. I would not have 5% of the possibilities that I have in my life if not for FRC. It has totally changed my life in every possible way. It's an amazing program, and when I see a student that's putting forth tremendous amounts of effort into it to grow, it's a wonderful thing, because I know that they're going to go off and do some really cool things.
Absolutely. Yeah. I mean, I've met so many amazing people over the years. I've made a lot of my friends that I would consider like, my best friends for life through FRC. There's just so many cool people in this program. So definitely stick with it, and just try to learn, learn something new all the time.
Never stop learning.
Now we will be wrapping up the questions and answers for this evening. Thank you, everyone, for coming to this week's First in Focus, and thank you, Ryan and Sam from Thrifty Bots. It was nice meeting you, and we hope to see you again in the future. A video recording of this presentation will be on the 2468 YouTube channel in about a week. This will be our last spring First in Focus session this year. Keep an eye out for future First in Focus sessions. Thank you everyone again for coming, and we'll see you next time. Have a great evening.